Hi, I'm Mr. Kangas, and in this section we're going to simplify an algebraic expression that has parentheses in it, which will require us to use step 2 of the process, distributive property. Okay. So, to start, I need to use KFC on any subtraction. There is subtraction inside my parentheses. Now, the reason we're using KFC is to make sure all my subtraction turns into addition, because my goal with the first two steps is to get rid of any parentheses and to change all of my operations into addition, so that when I get to the third step, I can add in any order I want. So the first step, KFC, is going to require us to rewrite the problem now. Very important you rewrite the problem as you're doing your work. The reasoning for this is because it makes it very easy to find your mistakes if you made one. And if you're one of my students, it is very important that I am able to find your mistakes so that I can help correct you when you make them and get you headed down the right path. Also, I tell this to my students, and this is true for anyone, if you're thorough in the way you show your work and you rewrite the problem every step, you're less likely to make mistakes, and if you make mistakes, you're more likely to catch it yourself without having to ask somebody to look at the problem. And I have many, many students who can testify to that. So, step 1 is done. There's no more subtraction. I'm going to put some parentheses around the negative 2x just to keep the plus sign and the negative sign separated. But inside the parentheses, this is 4 plus negative 2x. So, distributive property tells me to take the number on the outside of the parentheses. It's right next to them. There's no sign between them. So I'm going to take this number on the outside of the parentheses. I'm going to multiply it by both numbers inside. There is an explanation for why that works in the section on distributive property, which is chapter 3, section 1. So we're going to do 2 times 4 and 2 times negative 2x. So at this point we need to rewrite the problem. We have negative 3x plus 2, plus 2 times 4, which is 8. Keep the sign in the middle, plus 2 times negative 2x, which is negative 4x. Because when we do 2 times negative 2x, remember negative 2x means we're doing negative 2 times x. We have all multiplication here, so I can do it in any order I want. The only two numbers that can be multiplied together here are 2 and negative 2. And 2 times negative 2 is negative 4. So you're left with negative 4 times x, which we like to write as negative 4x. At this point, I have completed steps 1 and 2. I'm going to combine my like terms, but before I can, I'm going to reorder the problem. I'm going to group my like terms together. So we have negative 3x plus negative 4x plus 8. So negative 3x plus negative 4x gets me negative 7x plus 8. These are not like terms. They cannot be added together. They don't end in the same variable. I have completed my problem. Now, I am going to back up a couple steps and show you an alternate way to do distributive property. Some of you may have been confused in the way I did it the first time. Another way to do it requires an extra line of step. So when I rewrite my problem here, I could do negative 3x plus 2 parenthesis 4, 2 times 4, that's what this means. Whenever a number is next to parentheses and there's no sign between them, it means multiply. So this means 2 times 4. Keep the sign that's in between the numbers inside the parentheses, so keep that plus sign. Then we're going to do 2 times negative 2x, or in other words, 2 parenthesis negative 2x. So the next line would be negative 3x plus 2 times 4, which is 8, plus 2 times negative 2x, which is negative 4x. I would then reorder my problem, putting negative 3x and negative 4x next to each other, add them, and be done. Again, if you have any questions or concerns, maybe you think I should do something different in these videos, please email me or go to the forum on my webpage, make a suggestion. Please let me know. These videos are for you, so I want to make sure that they are as good as they possibly can be.